All right, so it's a review day. The A-Dayers have graded the B-Dayers quizzes. Thank you, A-Dayers. You guys are going to do that in the future as well. That way, B-Dayers, you're going to be able to pick up your quizzes on your day and then be able to see what you got and study off of those. A-Dayers, fortunately, you have to come in from third period on to pick up your quizzes. But you'll be able to see your grades third period on. So we've done that. We are now going to talk about the test, what's going to be on it, what to expect, and how to prepare for it. Then we're going to go over the homework from the last lesson, and then we'll finish by quizzing on the last lesson. A-Dayers, we're going to grade that quiz. B-Dayers, you're just going to turn this quiz in, and then you'll be able to find the answers online at the end of the day. So the entire test is no calculator. It's about 25 questions, most of which are going to be multiple choice. Most of our tests, most of the test questions are going to be multiple choice. Does not make it easy. Okay, you will discover AP multiple choice test questions where every single answer looks like it could be the right answer. And every single time you do a question, if you make a mistake and you get a certain answer, that mistake, that incorrect answer will be an answer choice. So a lot of people circle incorrect answers, but with a lot of confidence. Okay, so for these tests, for these multiple choice tests, it does not make it easier. It actually makes it harder, okay, because there's no partial credit. Multiple choice means no partial credit, which means you can't make mistakes anymore in math class. Sorry. We're expecting perfection. Be neat and organized with your work, and if there's a negative sign, don't let it disappear on you. If you're doing something, you're not sure if you're doing it correctly, start over. Sometimes just starting over is going to help you. There will be some free response questions that we will have where you'll have to understand typically more concepts, or there might be word type problems, but similar problems than what you've seen on the quizzes. How are you going to study for the test? Well, the test questions are similar in difficulty to your quiz questions. Your first priority, if you have just a little bit amount of time, is to redo your quizzes. Redo them multiple times. Okay, all of the quizzes, blank copies of the quizzes will be on the website, as well as answer keys. I can show you, they're going to be in a folder labeled quizzes. I don't have them up right now, but go ahead and look on your on the website. You will be able to find the quizzes. The second priority is to use the review on the website for extra practice. So I used to print out huge packets of reviews, but I don't collect them, and they ended up being kind of like a waste of paper. So I want those of you who actually are going to use the review and do the review, you can access it, and you could print it out, or you can just look at your, your computer while you're doing it. So most likely there's going to be an extra folder where we're going to have quizzes by unit with the blanks and the answers. And then in the lessons page, we have the review. There's actually a review quiz, which is a good practice that you might want to do as well. Consider this a quiz. And then extra practice problems. Here's some limit practice problems. Here's some analytical limit practice problems. And then the answer keys are right underneath it. Okay? Including for the quiz, this review quiz. So definitely do that for extras, but start with the quizzes. The quizzes will be on this page. Question?
So for like the past, I compared to people that have done the review, has helped them just as much as redoing it.
No. So quizzes are the first priority because the quizzes are made by me, and I make sure that once you guys get to the test, there's no huge surprises, whereas the reviews are just extra materials made by somebody else that I've just kind of compiled for extra material. Does that make sense?
Yeah. So then the review quizzes, are they different than the quizzes we've already taken?
So this is the only unit where I made a review quiz, and I decided it just wasn't worthwhile. So so the review quiz is made by me. So do that. Does that make sense? Any stuff made by me, you should definitely do and do multiple times. The review is just extra practice. I always like to tell people at the beginning of the year to study by doing problems until you can't get them wrong, not until you get them right. Okay, so if you have difficulty on a quiz question and you got it wrong the first time, and then maybe you're doing the quiz again and you got it wrong again, well, maybe you do it again and you say, or you look at the answers and you say, oh, I know what my mistake was. I'm good. Let's move on to the next question. No. Do the problem that you've gotten wrong multiple times until you know exactly where your pitfall was, and you will never make that mistake again. If you do that, you're going to do really well on math tests. Okay? So study by doing problems until you can't get them wrong, not until you get them right. And that's it. That's my advice for the test. Redo your quizzes. Use the review on the lessons page for extra practice. 25 questions, 16 multiple choice. Multiple choice, there's no partial credit. All right or all wrong. All right, let's go over questions from your homework. I don't have any practice for today. We don't have enough time for practice, so we'll just go over the questions that you might have, and then we will quiz. One, three. Yeah, what do we got? 72. So we got tan squared of x over x as x approaches 0. Okay, to tackle this guy, I would write tan squared as tan x times tan x. And then I'd also include the 1 over x just off to the side. We can do that. We can split up our fractions like this. For every tan x, I'm going to rewrite as sine over cosine. Then I can move things around however I want. I can either split these up so that it's a sine times a 1 over cosine times a 1 over cosine times a 1 over x, or I can know that I can just move the x to be under one of the signs, and then I'll have 2 1 over cosines and a sine. Okay? This is totally legit and legal. We can do this. We want to find the limit as x approaches 0 of this. You would treat them all as separate limits, but we don't have to necessarily write it all out that way. I know that this limit is 1. It helps me get rid of this x, which is a problem, which is not letting me plug in 0. Then I would be plugging in 0 everywhere else. Every time I have the cosine of 0, that's 1. So this is 1 times cosine of 0 is 1 over 1. However, the sine of 0 is 0. Now, it's okay that it's 0 here because it's not in a denominator. It's in the numerator. So having that 1, 0 means the entire thing is 0. That's my answer. Sherwin? 78. Right, I kind of showed you this in the lesson, I thought. They give you a hint. I'll show you a way that I would have done it. The answer ends up being 2/3. I showed you that trick where you can kind of, only in these limit problems, pull out numbers. You're not allowed to do that in any other types of problems. You're not even allowed to do that in this problem. It just works. But to do it properly, we would actually give the top and bottom an x by multiplying by x over x. I can do that. It's not going to change things. And then I would write this as 2 separate limits. The limit of sine of 2x over x, and then x over the sine of 3x. And then we should remember that the limit as x approaches 0 of sine x over x was 1, but it's the same as x over sine x. That's also 1. Okay, and that's kind of how we do this. Now, the proper way to do this is to replace variables. say, okay, u is, I'll kind of do it separately, and I'll show you the proper way. Then I'll show you how you can just make the exception and do the trick. Let's say, okay, u is 2x. Let's switch the variables. That means x is equal to 1/2 u. This becomes the limit as 1/2 u approaches 0. It's the same as u approaching 0. This is the sine of u over 1/2 u. Well, that's the same as 2. That's not a 2. It's the same as 2 times sine u over u. So that limit is 2. Okay, so that's my first limit. Now I can tackle the second limit. Limit as x approaches 0 of x over sine of 3x. Well, same deal. Replace the variables. Maybe you use like another variable instead of u's. But if it's a separate limit, then you could do this. U is 3x. That means 1/3 u is equal to x. We would then have the limit as x approaches 0 of 1/3 x over sine, u, 1/3 u, sine of u. Gives you 1/3 u over sine u. Remember from last class, this is 1, so this gives you 1/3. You can then multiply the two limits together to get you 2/3, which is the exact same thing as if you kind of pulled these out and said, oh, sine x over x cancels, and this is just 2/3. Don't do that. You're not allowed to do that. Wink, wink.
So, we're not allowed to do that, like,
Wink, wink. You got me? Just get the right answer. It's only for these that I'll let you do this. Okay? 80? All right, this one's tough. Tough because you remember we had another limit that we kind of talked about numerically. That is the limit as x approaches 0 of 1 minus cos x over x. This is actually equal to 0, right? Well, I'm close to having that. If I factor out a -1, I'll have 1 minus cos x, or negative cos x plus 1. And then I could put that with an x, and then I could put a 2x over here. And then if you think about it, this is 0, but this still has a 0 in the denominator. So we're kind of stuck. We don't want to say it does not exist because this limit is actually 0 over 0, which is indeterminate. Okay, because this is just 0. This is a 0 in the denominator. So this is still saying I'm stuck. Don't stop there. So we need to try to figure this out a different way analytically. Here's the trick. I'm going to multiply by the conjugates. Why? Because I know when I do that, it will create a cos squared x minus a 1. And then in the denominator, I'll have the product of 2x squared and that conjugate. Why does that help me? Because it's sine squared x, exactly. Remember that sine squared plus cosine squared is equal to 1. That means sine squared is equal to 1 minus cosine squared. Well, I'm close to being able to make that sine squared. I need it to be 1 minus cosine squared. What do? Yep, factor out a -1. Now I can say this is negative sine squared in my numerator. So the limit as x approaches 0, I'd have negative sine squared over 2x squared cos x plus 1. Now, use, our algebraic manipulations of fractions, rewrite our fractions, our properties of fractions. I'd have -1 sine x sine x. I could put the 2 underneath the -1. I could put an x under 1 sine x. I could put an x under another sine x. I then have 1 over cos x plus 1. This is all separated out. I can find the limit as x approaches 0 of this. This is -1/2. This is 1. This is 1. I would plug in 0. I have 1 over cos 0 plus 1. This is 1/2. So it's -1/2 times 1 times 1 times 1/2. This is -1/4. If you ever see a 1 minus cos x, but there's 2 x's in the denominator, then think about multiplying by the conjugate. If there is just 1 x in the denominator, well, then you can go ahead and say it's 0 up here. That is 0. But once we have an x squared, then we kind of have still an indeterminate limits. 0 over 0 typically means there is a limit. We just don't know where the location is. 82. Great. This is a perfect one to do. I'm glad we chose this one. Not because it's on the quiz, because all of you that thought you did it right, you didn't do it right. You got the right answer, but you didn't do it right. A lot of you said, oh, let's just cube everything. Cube the top and the bottom. Anybody do that? Right? You're not allowed to cube things. It changes it, right? Think about 2/3. If I cube the top and the bottom, is 8/27 the same as 2/3? No, it's not. If I tried to simplify this fraction, it can't simplify to 2/3. So cubing things is illegal. It changes it. We can multiply things by something over the same thing, and that doesn't change things. We can add 0. That doesn't change things. We can't square or cube things. That does. So I do need an x, right? Because I want sine x over x. What can I multiply the cubed root of x by to give me x? So the cubed root of x times the cubed root of x is typically what people say because they know that root x times root x is x. Okay? However, the cubed root of x times the cubed root of x is x to the 2/3, not x. Why is that? You need to remember your properties of exponents when we're multiplying. What is this? Good. X to the 5th, not x to the 6th, right? Well, here, this is x to the 1/2 times x to the 1/2. 1/2 plus 1/2 is 1. That's why it goes away. It does not get applied to every single root. A cubed root is the same as what power? 1/3. Well, 1/3 plus 1/3 is 2/3. That doesn't give me an x. So let's change this up. What do I multiply x to the 1/3 by to give me x? X to the 2/3. Now I have x. So I need to multiply the top and the bottom by x to the 2/3. Then I have the limit as x approaches 0 of sine x over, this is just x, times x to the 2/3. This is 1, this is 0. The answer that you got, which is correct, however, you reached it the incorrect way, is 0. All right? Sure. Let's keep going. 74. Did you try to plug in pi?
I didn't really know where to start on that. No, I didn't know.
Right. This is another good example to do, because remember, you should always attempt to plug in the value first. And this is just a different variable. It's a phi. You plug in pi, you have pi secant of pi. Well, that's pi times 1 over the cosine of pi. Cosine of pi is -1. So we have pi times -1. The answer is negative pi. It's easy. Remember, for limits that don't approach 0, for like sine x over x, this limit is not 1. Right? Everybody thinks they see sine x over x, the limit will always be 1. Well, if it's approaching pi, this is the sine of pi over pi, which is 0 over pi, which is 0. And that's okay to have. It's only when x is approaching 0 can we say that this is 1. All right, any other questions? 81. We got to start our quiz soon. Don't worry, we have plenty of time. Oh, that's a good one. I don't think I've done this one. Sine of x squared. So I'm thinking of, rewriting it out, but that doesn't really help me. So that isn't going to work. I'm thinking now of replacing the variable, similar to how we do with others. So u is equal to x squared. That means x is equal to plus or minus root u. Let's see what happens. I have the limit as, this would be plus or minus root u approaching 0. It's going to be the same as u approaches 0. This is the sine u over plus or minus root u. Well, I'm kind of going to do what we did the last problem that we did with the x to the 1/3. I'm going to multiply this by root u because it works over root u. I'll end up with root u sine u over u. This is 1, plug in 0, this is 0.
Can't you just make it sine x over x and get the rule?
No, because this is in parentheses. It's captured by the sign. We cannot release anything inside of the sign until we get rid of sign. Okay, so I plugged in 0 and sine u over u is 1. Let's see what the book did. Well, they did it numerically. Good. They multiplied by an x over x to give x times sine of x squared over x squared. They said, oh, you can just replace this. This is just going to be 1. Plug in 0. It's the same process as what I did. Just they went up with degrees. I went down by substituting. Okay, but correct answer was 0. Anything else? Let's go ahead and take our quiz now. So go ahead and pass up your homework. So you guys are going to take the quiz. We will then collect and grade. B-dayers, you guys are going to take the quiz. You're going to turn in the quiz. we're going to grade B-Dayers your quiz on Wednesday after you take the test. I know that's not going to help you, but we're just going to have to do that since I'm absent tomorrow. So B-Dayers, you're going to take the quiz. You're going to turn it in. You're going to grab your graded quizzes. Go onto my website to see the answers and to see what you did wrong. And then we are going to grade this quiz either the day of your test, but most likely the first day of the next unit. Okay, so you won't know your grade on that quiz until later. All right. Here comes your quiz.